Hi, it's Stanley Lake Physics. Today we're going to start talking about optics and go through some basic definitions and also talk about how a plane mirror works. So if you've never thought about it before, I want you to look at this picture and think about how that image, the version of this vase or urn or whatever it is, can be inside the mirror. I mean, it looks like it's somehow in the mirror, but we know that there can't be an in the mirror because mirrors are flat. And if we walked around to the other side of this mirror, we definitely wouldn't see this here, even though it looks like it should be in the mirror. So how does it get there? How do we get an image of a likeness of this image that can be inside the mirror? And that's what we're going to attempt to answer today. So I'd like you to go to your optics notes. So if you haven't already gotten there, go ahead and get there. And we're going to go through some definitions. So the first is reflection. Reflection is when light rays bounce off of a surface. And I'm going to come back to normal. I'm going to do incident ray first. Incident ray is a ray of light So it's an arrow that represents a ray of light going in towards the mirror. The reflected ray is an arrow representing the ray of light reflecting back off the mirror. And a normal actually just cuts those in half. The normal is a dashed line that is perpendicular to the surface of the mirror, right where the incident ray is. Now, the reason we even bother with a normal is so that we can do these next two, which are the angle of incidence and the angle of reflection. It gives us a place to measure those angles from. So the angle of incidence is the angle between the normal and the incident ray. The angle of reflection is the angle between the normal and the reflected ray. And just like many things in geometry, when you're measuring an angle, we use the Greek letter theta, which looks like an O with a line through it, to represent the angle. So this is theta, and then when we put a little I on that, that's the angle of incidence. So theta I is the angle of incidence, and theta R is going to be the angle of reflection. So taking a look at our picture here, the incident ray is going to be coming in here. The reflected ray is bouncing back here. The normal is the dashed line perpendicular to that. Then the angle of incidence is this angle right here, and the angle of reflection is this angle right here. So we're going to go ahead and label those. So if you click on your picture, you should get an edit button. This is our normal, our incident ray, reflected ray, angle of incidence, angle of reflection. Okay, a few more definitions. So a real ray is an arrow, a solid arrow, representing a ray of light that actually emits. A virtual ray is a dashed arrow that your brain creates. And we'll talk about that in a little bit. The object is anything that is allowing light to be emitted that can be seen in a mirror. We usually use an arrow. Arrows are nice because they're easy to draw and you can tell which way is up. So we usually use an arrow, but it could be anything. I'm the object when I'm brushing my teeth in the morning in front of the mirror. The urn was the object in our picture. The image is the likeness of the object that's produced by the mirror or lens. And then there are two laws of reflection. One of them is that the angle of incidence has to equal the angle of reflection. Here I'm going to copy and paste. And the second law, besides theta r is equal to, is that incident and reflected rays are in the same plane. So if I were to shine a light beam off of my mirror, if I shine it in sideways, so if I shine it in sideways, it's going to continue out the same plane. Or if I shine it in up, it's going to continue up in the same plane. This is what allows you to be able to spy on people with a mirror. So if you're holding a mirror in front of you, you can see that person back there in the same plane. So, and then the angle of incidence is equal to the angle of reflection. So how far I need to look into the mirror on the side to see back the other way. So these two angles will be the same. Okay, so now we're going to start talking about this plane mirror and how we see this image. So the first thing that I'm going to do is show you a quick video, because this explains it really well. Show you something else, and we'll end with a question that you can ponder. So a plane mirror is just a flat mirror. So the rays come from the object, then reflect, off the mirror into your eyes. Your brain knows that light travels in a straight line. So notice I used a couple of words here. Virtual rays. So virtual rays are dashed lines. So notice that these are dashed lines in the picture. That's because they're not really there. Our brains put them there. They're here in our heads, but they're not actually inside the mirror because there can't be anything inside the mirror. So they're virtual. It's a virtual reality. It's up here. And traced back just means that I'm taking these reflected rays and extending them backwards into the mirror. So that's what I mean by traced back. And they appear to meet behind the mirror, which is where our image forms. So we see now, that's weird if you're thinking that's really strange. This is actually our usual experience with mirrors. And later on, we're going to take a look at a real image, and those are weird. We're not used to seeing the actual rays as a real image. So virtual images we're much more comfortable with because we see those all the time. So I want to show you this one more time. We're done with the notes, but I want to show you this process again because it's really kind of cool to me that you can form an image this way. So we have our object. It's right here. The incident rays are coming, these rays of light, you can imagine an infinite amount of rays of light that are coming from our object. And they're going to go into the mirror. This is our mirror right here, our plane mirror, our flat mirror. So I'm going to imagine two different rays of light coming from the bottom of our object, which you'll notice is an arrow, and two rays of light coming from the top of our object, which you'll notice is the arrowhead. So we've got a ray coming in here, ray coming in there. And now we know that the angle of incidence is equal to the angle of reflection. So if I make some normals, I can then see what those angles would be. So for this incident ray, my reflected ray will come out at the same small angle. And the same thing here, this reflected ray will come out at the same angle, and they're going to bounce. It's a way of helping us predict where they're going to reflect. So now those are my reflected rays, and those go into my eyeballs. So my eyes are seeing these green rays because those are the ones that are getting to my eye. Now my eyes think that those rays had to have been straight lines because rays of light are straight lines. If you shine a laser, you know that the light goes in a straight line. So that means my brain is going to trace these rays backwards into the mirror where they can't actually be. So they're going to be virtual rays. So notice that they're drawn with dashed lines because they can't really be there. So the real rays that actually exist, we make solid, and the virtual rays that can't really exist, we make dotted. I'm going to get rid of me for a minute there. And if I show my image is going to form right here. So right where those rays meet. So the image is inside the mirror the same distance that my object is in front of it. And there's a link to this so that you can take a look at it on the main page. So now the question that I have for you is somebody is here seeing this image. So they're looking at the image inside the mirror, and that image is forming in your brain. So we're seeing it right now. A student asked me this question many years ago, and it still stuck with me, and I don't know what the right answer is. But suppose that this happens in a place where there are no people. Does the image actually exist? Since the image is forming in our brains as a virtual image, um, if there's nobody around to actually see this image, does it actually exist? So I'll give you that to think about on the snowy day. Um, and I will talk more about this in class tomorrow. So have a great day, everybody. Enjoy.